mind when you do these questions and how to unpick information in a difficult question, yeah? But they are mainly aimed for year 13 students, and I know sometimes year 12 students book and they are confused. I'm going to do the first question is year 12 content, but from a year 13 paper, yes, differentiation, year 12 differentiation. And I can skip a few questions, do the probability question that again is a year 12 question until the very end. Everything else is going to be more year 13. So if you're in year 12, I think the first couple of questions will make sense, the others not. Yeah. Okay, so please everyone, this is a super typical differentiation question. So it's very likely that you find something quite similar. We have a manufacturer produced pain-relieving tablets. Each tablet is the shape of a solid circular cylinder. So this one, the base is X. Sorry, I'm getting everyone in. And the height of the cylinder is H. Given that the volume of each tablet has to be 60 millimeters cubed, and I would highlight this information, so don't forget that we're going to use this thing. We have to express H in terms of X. Yeah, I would say, you're going to see in a minute, if you have seen questions like this one, that this is unlikely that they tell you. So this question is quite scaffolded. It's not going to be always the case. So sometimes they start straight away with this one, and it will be maybe 4 marks for that. How can I find H in terms of X? Because I want them. What do you think I can do? Ryan, tell me, what can I do?
Can you just use the formula for the volume and then sub out the V for the 60?
Exactly. So this numerical information is precisely for that. I can make the volume equals to 60, and the volume is going to be in terms of X and H, and I'm just going to make H the subject. Yeah, so let's do that. Remember the formula of the cylinder? Area of the base, or the cross section, because it really is a prism, multiplied by the height. Yeah, so I'm going to do that. The volume is going to be area of the base, so pi r squared. My radius is X, it's called X, multiplied by H. So that's the volume, and we say that that's equal to 60. And we have to make H the subject. Yeah, so just live in terms of pi. So H is going to be 60 divided by pi x squared. That's what we need to do. That's that. It's 1 mark, so don't expect too much. Now, we have to show that the surface area, we're going to call it A, of a tablet is given by this expression here. How am I going to do the surface area of the tablet? Who can tell me? I'm going to find the surface area. Who remembers how to find the surface area? Emily, tell me.
Can you break it down into the shape? So you've got 2 circles on the top, find the area of that, and then you've got a rectangle to find the area of.
Exactly. So if I open this, imagine it's like a toilet paper roll. Remember, I have a rectangle and 2 circles. The area of the circles are going to be pi x squared, and I have 2 of those. And the area of the rectangle, this side is H, and this side, remember, is the length of the circumference, yeah, which is 2 pi r. So this is going to be 2 pi x. So the area of the rectangle is 2 pi x h. Yeah, that would mean that the area is going to be this plus 2 times this. So let's going to write that and see what we have. The area. So for part B, very common question. I'm sure it's sounding bells, it's ringing bells. So the area is going to be 2 pi x h plus 2 times the area of the circles. Yeah. If they don't tell you this part here, you will still be doing this surface area. But now look at the expression that we need and the expression that we have. What is the difference? We have these 2 pi x squared, and here we have an h that we don't have. But because they have asked us to write h in terms of x, we can substitute this here and have everything in terms of x. And that's what we are doing. Yeah. So I'm just substituting h by that, which means I have 2 pi, instead of h, I'm going to write that 60 over pi x squared, and then the rest is the same. I can cancel one x. I can cancel pi, and I'm going to multiply the numbers, yeah? And I'm going to write the things in the same order that they do. So I'm going to write the 2 pi x squared first. Not that matters, but always we try to write an expression in a way I would be as writing it as possible as it is. So 2 times 60 is 120 divided by x. So plus 120 divided by x, that you see is exactly this expression, yeah? So most of the questions are not going to tell you this. They are going to tell you, so that the surface area of the tablet can be given that way. Your surface area, or whatever they are asking you, sometimes it's the volume or sometimes it's a cost, is going to be usually in terms of two variables. And they are going to give you some numerical information. This numerical information is to eliminate one of the variables. Yeah, so you are going to make whatever variable you don't want the subject and substitute in the expression that you have in terms of the two variables. Does it make sense? So the sequence would be the same, but they might skip this thing here. Yeah, they go straight into find the surface area, and you don't have h there. So the way of eliminating h would be using this information. Is clear for everyone? Yeah. Okay, then this is a differentiation question. So they are going to ask now to maximize or to minimize this volume or this surface area. So they say a manufacturer needs to minimize the surface area of the tablet. Use calculus to find the value of x for which a is minimum. What are we going to do? Can you tell me in the chat, please? As briefly as you want. How I'm going to find the minimum. That was brief. Fraser, yes. Yeah, exactly. I'm going to differentiate, and I'm going to make my derivative equal to 0. Exactly. Yeah. So anytime that I have to maximize or minimize something, I derivate my expression, I make the derivative equal to 0, and that's going to give me the value of x that gives me the minimum or the maximum value. So let's going to do that. I hope for those in year 12 that you have done differentiation already, because this is very simple. So I'm going to write this x in the numerator because it's easier to differentiate, and I'm going to do dA by dx. Derivative of this bit, the 2 goes to the front, so I have 4 pi x to the power 1. So this is 4 pi x to the power 1. And then this one again goes to the front, so minus 120 x to the power of 1 less, so it's going to be minus 2. Sorry. Yeah. And now this derivative must be equal to 0. Yeah, to find the minimum. How am I going to solve this equation? Who can tell me? Maria, hello. Fraser.
Add the 120 over x squared to the right-hand side, and then multiply through by x squared, and then you can just solve it from there.
Exactly. When you have an equation like this and you have a negative power, it's very difficult to see what to do with it. So my recommendation is that you bring it back to the denominator. So if you bring your x back to the denominator, your x squared is much easier to see. Yeah, because now what you want to do, eliminate the denominators. I'm going to multiply by x squared, like Fraser said. Yeah, and bring things around to solve it. So if I multiply everything by x squared, sorry, if I multiply everything by x squared, I have 4 pi x cubed equals to 100. Yeah, so I multiply by x squared and bring the 120 to the other side. That will mean pi x cubed is 30, no? So x is going to be the cube root of 30 over pi. Now we check if we have to give that answer to any decimal or any significant figures. No, so it's up to you. If you leave it like this, the calculator is not going to do any better. So I would probably leave it like this. If you have units, give units. Yeah, so x is in millimeters. Look, So I'm going to write millimeters, and I will probably leave it like this. Did you get the same answer that I do? Yeah, okay, I see people nodding, thank you. That's the value that gives my volume maximum or minimum. I know only that it's a stationary point. Now, look what they ask you there. Calculate the minimum value of A. So we found the value of X that gives us the minimum A, but not the minimum A. So we are going to find it now. How am I going to find it? How can I now find the minimum A? Farah, how am I going to find it?
You would just substitute that value into the equation that we're given.
Exactly. So now that I have the value that is giving me, the minimum value, I just substitute in the A. Yeah, it's like X and Y. I know the X, I need the Y. So we have this formula for the minimum area. So just we are going to substitute that. That was C. So the minimum surface area is going to be 2 pi times, and instead of X, I have that cube root of 30. That's why I could keep probably the whole thing, because then in the calculator it's going to be fine, and we are not going to be missing decimals. So please find this with me, because you know I made mistakes with this in the calculator many times. So I get 84.84. You get the same value? Jonathan, tell me. Do you have a question?
Is it all if I put it to two significant figures, like 85 millimeters squared?
Yeah, it would be okay.
Okay.
84 point, mainly because they are not saying round to anything. If they were specific of the rounding, maybe you should be careful, but they haven't. So, and now they say to the nearest integer. So this one is the one that we have to round. So I get 84.84. So to the nearest integer, this is going to be 85. Is area, and we have millimeters, so millimeters squared. Yeah. Let me check. We have the marker scheme here. Abby, tell me, do you get something different?
Do we assume it's in degrees unless they tell us otherwise?
We assume what? Sorry?
We assume it's in degrees, not radians.
Degrees, but we don't have any angle here. What did you mean? Where did you want to have degrees or radians here?
Oh, never mind. I see. Never mind.
You saw the pi or the 2 pi and you thought that's radians or degrees. We don't have angles. The 2 pi is just the formula of the area of the circle or the circumference, yeah?
Yeah.
Okay, and I'm using millimeters because we have millimeters, so those are the only units. Now, the last bit is show that this value of A is a minimum. Can you tell me in the chat what I'm going to do, please? As short as you want. What I'm going to do to prove that this is a minimum. Exactly, I'm going to differentiate again. And it's going to be a minimum if the second derivative is what? Can you tell me positive or negative in the chat? So plus or minus? Second derivative is going to be plus or minus? Exactly. We want to say that the negative is the minimum, but no. Yeah. So let's going to do that very briefly. For D, I'm going to do the second derivative of A. So I'm starting from here. This is my first derivative. I'm derivating again. So this one is going to give me just 4 pi. And the second part, this one goes multiplying. So minus minus becomes plus. 120 times 2 is 240. And x goes down by 1 more. Yeah. This, when I substitute the x by the value, the cube root, is going to be positive. In fact, every time I substitute any positive value, this is all going to be positive. Yeah, so I don't even care too much about the value. This is going to be positive, therefore it's a minimum. Yeah. Does it make sense? Super typical question. Areas, volumes, perimeters, surface areas. The questions are, there are thousands of questions like these ones. One note here, again, they might combine all these together. So the question can be just like more squeezed. They can ask you, find the minimum value of A, fully justifying your answer, something like that. So find the minimum value of A, fully justifying your answer. To get the marks, you are going to do the same that we just did. So we are going to find the first derivative to find the value that gives us the minimum or the maximum, substitute to find the minimum area, and then do the second derivative to double check that is a minimum, because it could be a maximum. Yeah, we know it's going to be a minimum because they're asking us the minimum value, but still to fully justify your answer, you have to do the three things that we have done here, even if they just say find the minimum and justify. Does it make sense? So please don't lose marks for just finding the value and then not showing that it's a minimum. You have to check it's a minimum. Yeah, and you will lose. So this sometimes could be 7 marks altogether, for example, or 8 marks. Probably not that much, but is it clear, everyone? So this is a fully year 12 differentiation question. I say I'm going to skip a few questions and go to the probability, because this one again is quite simple for year 12 students. And then after that is going to be more complicated. So if year 12 students after that you want to leave, I would understand. Yeah. Probability question, very simple. The last bit is year 13, the rest is year 12. So we have a Venn diagram. We have how 25 people travel to work. So we have all the numbers here. We don't have to complete anything in the Venn diagram. B, bicycle, T, train, W, walk, and write down 2 of these events that are mutually exclusive. Can you tell me in the chat 2 events that are mutually exclusive? And I'm going to remind you in a minute what it is, but I want to see if you remember. B and W, so B and W, some people, B and W, yeah, or T and W as well, yeah. Okay, so mutually exclusive is when they don't have, perfect, exactly, Atrika, when they don't have intersections. So there are 2 events that they don't have anything in common, like this one and this one. So they don't have people that go in bicycle or walking, or this one and this one. There are not people that go on the train and in the walking. Yeah, so that's mutually exclusive. The intersection is, or the probability of the intersection is 0. Yeah, that's your justification, your reason. Yeah, let me show you what they say. So they say which ones are, and they say there is no overlap between the events or cannot happen together, or the probability of the intersection will be 0. You can write it. Is it clear for everyone? Now, determine whether or not B and T are independent events. This is something that sometimes you forget, because you start to think, what does it mean? It means that one doesn't affect the other, but how can we check that in probability questions? So what is the way of checking this? Can someone remind me? Who remember? Fraser.
Is it that the probability of A multiplied by the probability of B is the probability of A and B?
8 times B. Do you mean? No?
Yeah.
Yeah, exactly. Yes. So, and in fact, this is in the formula booklets. Yeah. So you don't have excuse to forget this. They are independent. So 2 events are independent if the probability of the intersection is the product of the probabilities. So in this case, sorry, product of the probabilities. Don't start thinking if one affects the other, or no, don't do that. Just use the probability. So in this case, we have to check if B and T. So B and T, probability of the intersection between B and T is 5 out of 25. Yeah, we have 25 people and there are 5 people here. So 5 out of 25. I'm going to do another page. I'm going to check if 5 out of 25 is equal to the product of the probabilities. So probability of B is 9 out of 25. Is this equal to 9 over 25 times probability of T, which is 8 out of 25 again. So 8 out of 25. Yeah, I would always double check. and this is not, yeah? Because sometimes the numbers look that they are not going to be the same, but then things cancel. And that means that they are not independent. Yeah, are they asking me to show that they are not dependent? No, they're asking me to determine whether they are. Because sometimes they say, prove that they are not, or prove that they are. In this case, they are asking me. So they are not independent. This is in the formula booklet. Don't forget, because it's very simple and they like asking you. Yeah. Then one person is chosen at random. Find the probability that this person works to work. So in the chat, can you all tell me, if I pick one person, what is the probability that person works to work? Come on, this question is a gift. It's one of those easy marks that you can do in 3 minutes. What is the probability that the person works to work? Exactly. 7 out of 25. Perfect, everyone. 7 out of 25. I don't have to do anything else. 7 out of 25. What's the probability that they travel to work by bicycle and train? Bicycle and train. What's the probability? Can you tell me in the chat? You can or not simplify. It's up to you. More people? Did you trust Fraser and Ryan? Yeah, exactly. When they say bicycle and train, they refer to these ones here. So those go in bicycle and train. Yeah. So it's 5 out of 25. You can simplify to 1/5. It doesn't matter. Yeah. Everyone. And now, so 5 out of 25, or if you simplify 1 out of 5. Now this bit is year 13 part. So in year 12, you revisit probability. You don't learn much new things, I would say. In year 13, you add the conditional probability. That again is not new. Given that this sentence is telling you that is conditional probability. So we know that something has happened, and from that group of people that we already know that something happened, we are finding a probability. Yeah. So it says, given that this person travels to work by bicycle, find another probability. So we know now our group is this group only. So we can kind of ignore the other. So we are going to write this, and now I'm going to do it here. We need the probability that this person that they will also take the train. So we need the probability that this person takes the train. Yeah. Given that we are going to draw a vertical line like this, vertical line, given that they travel by bicycle. Yeah. So this is what we know that happens. This person travels by bicycle, and we want the probability that they will also travel by train. There is a formula, again, it's in the formula booklets, that tells you that this is the probability of the intersection divided by the probability of the one that is already happening. So the second one, yeah? So always the intersection divided by the second one. What is the probability of the intersection? Bicycle and train is the one that we just found before, so it's 1/5. Probability of bicycle only, very quickly, is 9 out of 25. 9 out of 25. Yeah, and then we can cancel or whatever we need. So we have, what, 5 nines? No, what do we have? 5 nines, yeah. And that's our probability, yeah? In easy questions like this one, you can think about it. So they're asking me, what is the probability of them knowing that they travel by bicycle? So from this group, so my probability is going to be out of 9, not out of 25. What is the probability that they travel as well by train? And we know we have 5. So you can do them very quickly if you will understand conditional probability. But this is a bit risky. Yeah, you have to really understand conditional probability, the restricted sample space, and in some questions this is not that obvious. So my recommendation is that you use the formula. It's safer, it's in the formula booklet, and it always works. Yeah. Any question? No? Okay, then let's go into other questions. So let me show you this one. And again, if year 12 students want to stay, amazing. If you need to go and you think these questions don't make any sense for you, I won't feel offended. So a boy saves some money over a period of 60 weeks. He saves 10p in week 1, 15p in week 2, 20p in week 3, and so on until week 16. His weekly savings from an arithmetic sequence, which is not new really for anyone. Find how much he saves in week 15. So in these questions, remember, they are going to ask me basically two things in arithmetic or geometric sequences. They are asking me sometimes the term, so term number 20, or they are asking me the sum of the first 20 terms. And the problem that you make, the mistake that you usually make is sometimes you confuse both. So this one is a particular term. So if I have all the terms of the sequence, which one is the 20th? This one is the sum, all the terms up to the 20th. So don't get confused, read the question, because sometimes the wording is confusing. So what are they asking me here? S15 or A15? Can you tell me in the chat, S or A? What are they asking me? A15. So if they say how much he saves in week 15, not up to week 15. So it's just the wording. That's why it's a bit confusing for everyone. So in week 15, I need A15. How am I going to do that? Think about the general term or the nth term or an arithmetic sequence. Lara, tell me.
Do you plug it into A plus brackets n minus 1 multiplied by D?
Exactly. So the general term of an arithmetic sequence is the first term, that usually we call it just A, but we could call it A1 plus n minus 1 multiplied by the common difference. This formula is not in the formula booklet, but it's super easy to deduce. Yeah. So remember, first term is A, second term will be A plus the common difference. Third term will be A plus D, so 2D. So this number here is always one less than this number here. Yeah, that's why AN will be the first term plus one less D. Yeah. Common difference, because the sequence is A1 is 10p, A2 is 15, A3, 20, and so on. The common difference is just 5. We know that. So A15 is going to be the first term, which is 10 plus 14 times, yeah, so n minus 1 multiplied by the common difference. Yeah, everyone, does it make sense? Fraser, tell me.
You know, because this one's regarding money, do we put it into like pence or do we just leave it how the sequence has already said it is?
I would put it in, do you mean if we use pence or if we change to pounds or what?
You know, because like you said it's 10p, so is it 0.1 or do we just leave it as 10?
I think unless we get a very large number, I would still leave it in pence.
Okay.
Yeah, so for example, here we are not getting even a pound. Not even a pound? No, I've done something wrong. Haven't I? No, yeah, 80p. So I would leave it P. Everyone, and do you understand where we are finding A15? Because that's the mistake that you make. Yeah, phrasing sometimes is not clear. Now, calculate the total amount he saves over the 60 weeks period. Are they asking me S60 or A60? Can you tell me in the chat, please? S, yeah, it's clear now. So they say the total amount. So they are going to say up to or the total amount. So please be careful with your wording. S60, we have a formula, it's in the formula booklets. Yeah, so S60 is going to be n divided by 2. So n is 60 divided by 2 brackets 2 times the first term, which is 10. Yeah, exactly, that's the formula, plus n minus 1, so 59 times the common difference, that was 5. Yeah, so Sn is n over 2, 2a plus n minus 1 times d, and it's in the formula booklets, don't worry. So we find this, please do it with me. I get 9,450. Those are pence. And that's what maybe I would change to 94.50. Yeah. Yes, clear so far. Now, the boy's sister also saves some money each week over a period of M weeks. She saves 10p first week, 20p second week, 30p, and so on. So again, this is an arithmetic sequence. The common difference is 10 instead of 5. And she saves a total of 63 pounds in the M week. Be careful, because now we have pounds, but this thing is in p's. So don't mix in the same equation pence and p's without pounds and pence without changing. Yeah. So that m plus 1 equals to 35 times 36. Where do you think we can get this equation from? Svara, what do you think? Where did you think we can get this equation from?
I'm not too sure for this, but I just thought it was another arithmetic sequence one, so we would use the same formula.
It's an arithmetic sequence. We have everything, and they are giving me this information. How can I use that? What is that information?
Oh, that's the sum, so you'd use that. Yeah. Is that
Yes.
right? Okay.
Yeah, exactly. So I have another arithmetic sequence. If you want, we can do it here, so we can keep an eye on the question. So let me show you. So in this case, we have 10, 20, 30, and so on. My common difference in this case is 10. And I know the sum of m weeks, which means I'm going to have a sum in terms of m, but that's precisely what this comes from. So if I use this formula, so this formula here, I have m, yeah, m weeks, and we don't know this m, and we are going to write that in terms of m. So m weeks is going to be equals to 63 pounds, which in pence is 6,300. Yeah. M divided by 2, I cannot do much with that. 2a, because a is 10, is going to be 20. M minus 1, again, I cannot do anything with that. And d is 10. This must be 6,300. And this is where I'm going to get this. Yeah, so let's go to work on that. We expand, I'm going to expand this bracket first and then this one, reorganize. So please do it with me. So we have m multiplied by m plus 10m equals 2. So I'm just expanding this bracket, and these two are going to bring it not multiplying, I can divide by 2. Yeah, so I can divide by 2, and I have 5 and 5 here. So I have m, 5 plus 5m is 6,300. I can factorize the 5, and I have 1 plus m, 6,300. And look what it has to be. So it has to be m plus 1. We have this bit. And then when we divide 6,300 by 5, we are going to get 35 times 36. No? Yeah, so when we divide that, m1 plus m is 1,260. That can be written as 35 times 36. Yeah, and it comes from applying the formula of the sum and make it equal to 63. But we don't know the amount of the number of terms of the sequence that I'm adding, so I'm just leaving it in terms of m. Yes, everyone? Any question? No? Now, hence, write down the value of m. What are we going to do? Solve that equation. It's a quadratic, so let's going to do that. In fact, they are giving us the thing ready, no? Because m and m plus 1 is a number plus the consecutive 1. They have to be 30, so it has to be 35. And it's only 1 mark. If you don't realize, it's okay. You multiply. So if we multiply, is m squared plus m minus 35 times 36. That was 1,260 equals to 0. you solve it and you get m is 35, and the other one is going to be negative, no? The other one is going to be minus 36. Cannot be minus 36, so m is going to be 35. So either way, yeah, or you realize that they are helping you, giving your answer written this way, because you have a number plus the next one, a number plus the next one, multiply together, that means this is 35. If you don't realize, you expand your brackets and solve your quadratic. One is 35, one is minus 36, and cannot be minus. You cannot save during minus 36 weeks, yeah? So the negative cannot be. Is clear the question? Not difficult, but the wording, please be sure, because I see it all the time that they ask you A20 and then you find S20 and the other way around. So they are asking you, Lara, tell me.
I'm a little bit confused about the expansion part, like when you're expanding it before the last part of the question.
When I expand this?
Yeah.
Okay, so
Yes.
I expanded this bracket first, so I have 20 plus 10m minus 10. Yeah, and this 20 minus 10 becomes 10, and then I have the 10m. So I just kind of skipped one step.
Oh, okay. Yeah, I
So
see.
I expand this bracket and put all this together. So 20 minus 10 is 10, and then 10m. Is that the bit that is confusing?
Yeah, that was the bit.
Okay.
Thank you.
More questions? Anyone? No? Then let's go into do this one. So this is a year 12 differentiation question. And I'm conscious that some of you won't have seen year 12 differentiation yet. Year 13, sorry, year 13 differentiation. But I'm going to help you, and there are a few things that it's not like integration. So integration year 13 is difficult if you haven't seen it before, but this one is going to be easier. Yeah, exactly. So we have a curve with this equation. So it has, I don't know if you can see, e to the power of x root 3 sine 3x. Yeah, product of two functions. Now, find the x coordinate of the turning point on C where x is positive. So there you have a turning point here and a turning point here. They're asking us the one with the x positive. So this one, P. Yeah, and we have to give the answer in a particular way. We will go to that when we get the answer. How are we going to find the turning point? Derivative equal to 0. You know that. So I'm going to differentiate this function here. I read the chain rule, but we are going to use the product rule, not the chain rule. The chain rule is when I have a function of a function. But if I have a product of functions, what I'm going to do is to use the product rule. For those who haven't seen differentiation yet, and you haven't seen it with me, my students, for example, the product rule, if I have a product of two functions, when I derivate, is very simple. I'm going to differentiate the first function and multiply by the second, and then plus, I'm going to keep the first and multiply by the derivative of the second. Yeah, I'm going to derivate one at a time, multiply and add together. This is not in the formula booklet. The one that you have is the quotient rule, but not this one. But it's very easy to remember, yeah? So let's going to do that. If I think that this is U and this is V, I'm going to apply the rule that way, yeah? So derivative of this one, multiply by this one. Let's going to do that slowly and carefully. So dy by dx is derivative of this one. Remember, e to the power of 2x, for example, it was 2 e to the power of 2x again, yeah? As I'm going to remind you, when we have e to the power of 2x, the derivative is 2 e to the power of 2x. That doesn't go down by 1 or anything because it's not a polynomial, it's an exponential. So this is going to be the coefficient of x, which is root 3, e to the power of x root 3. Nothing changes with that. We will see this, don't worry. For those who haven't seen it with me yet. Then multiply by v sine 3x. That's the first part of the product rule. Yeah, and now I'm going to keep the first one and derivate the second one. So I'm going to keep this one as it is. So I have plus a to the power of x root 3, and I'm going to derivate the sign. Derivative of sign is cos. And if the x is multiplied by something, this 3 goes to the front. Yeah, I'm derivating this function here. So I have multiply by 3 cos 3x. Yeah, derivative of sine is cos. Derivative of cos is minus sine. And that's it. Yeah, so it's not that bad. And I'm going to make this equal to 0 because it's only minus cos when integrating. No, so when we have sine, the derivative is cos. And when we have cos, the derivative is minus sine. Thus, when you integrate sine, it's minus cos. When you integrate cos, you have sine. Yeah? Let's going to make this equal to 0. And for that, we can probably factorize this e to the power of x root 3, which is going to help you to see what we are doing. So I'm going to factorize, and I have root 3 sine 3x plus 3 cos 3x equals to 0. Yeah? Two factors. This one cannot be 0. So e to the power of something is never going to be 0. Yeah? So this one cannot be 0. The one that can be 0 is this one. So I'm going to solve a trigonometric equation. So I have root 3 sine 3x plus 3 cos 3x equals to 0. How am I going to solve this one? Ryan, what would you say?
Divide by cos 3x.
Exactly. So this week we have been seeing those questions where you combine this into r sine or r cos. This is not the case. We don't need to do that because this is 0. So I can divide everything by cos 3x. So I have tan. Yeah. Sine divided by cos is tan 3x. And cos divided by cos is 1. So plus 3 equals to 0. That means that tan 3x is going to be minus 3 over root 3. And I can find 3x straight away with the calculator doing minus 1. Then I will have to be careful to find the one that is positive and all that. Don't worry too much about the interval because I have only, well, we can check, yeah, but we don't even need to change the interval because we are going to find only that solution. Now, calculator in radians, please. So always be attentive to that. So tan minus 1 of minus 3 divided by root 3, I get minus pi thirds. Yeah? Minus pi thirds. But that's the negative one. That's the one is here. So I don't want this one. I need to find the next one. What is going to be the next one? So let me add a page. So I found that 3x is minus pi thirds. I'm adding pi, exactly. Remember tan repeats every 180 degrees or every pi radians, which is the same, yeah? So the next answer for 3 pi will be this plus pi, which is 2 pi thirds. Yeah, I will have more solutions, but I don't need them. This is the one that I'm looking for, the first positive one. And that will mean that x is that divided by 3. Yeah, because that's 3x, is that divided by 3. So x is going to be 2 pi divided by 9 radians. And that's the x that we are looking for. Yeah? Does it make sense? This other one could be this one. And because my function is only defined between minus pi thirds and pi thirds, I'm not interested in any other solutions that I could have. Is it clear? So I have a product of two functions. To differentiate, I use the product rule. And because I'm looking for the stationary points, I make that equal to 0. And on that way, I need to solve a trigonometric question that is not too bad. Now, Find an equation of the normal to C at the point when x is 0. When x is 0, I'm here, yeah? So x is 0, y is 0. I have that point. How am I going to find the normal? Do you remember? Emily, how can I find the normal, the equation of the normal? I need the gradient and 1 point. I have the point already. How can I find the gradient?
Is it the negative reciprocal of the gradient at that point?
Exactly. So the normal, remember, is perpendicular to the tangent. And I know how to find the gradient of the tangent. I'm going to use the derivative. And in fact, I have the derivative here ready for that. Please don't use only this bit, or this is my derivative, all this. The gradient of the tangent at the origin is going to be this derivative when x is 0. The negative reciprocal is going to be the gradient of the normal. And with that, I'm going to find the equation in 30 seconds. So let's going to substitute the x by 0 here. So for b, dy by dx is all this. And I want to find the gradient when x is 0. When x is 0, I have e to the power of 0 multiply root 3 sine 0 plus 3 cos 0. Yeah, x is 0. So this bit is 1, sine 0 is 0, cos 0 is 1. So what do I have? 3, no? 3. Yeah, if you want, you can use a calculator for these things. It's okay. That means the gradient of the normal, so the gradient of the normal, as Emily said, is going to be negative reciprocal. So the gradient of the normal is minus 1/3. And I know the point is 0, 0. So the equation of the line is going to be y equals minus 1/3 x. Yeah, you can use y minus y of the point, sorry, minus 1 of the point, gradient x minus x of the point. Yeah, this is 0, this is 0. So we have y equals gradient x. Yeah. Any question? Or you can use y equals mx plus c, and c, we know the y-intercept is 0. Yeah? Any questions? No? Next one? I see some 12 students staying. Well done. More. Again, a differentiation question. And again, not dissimilar. So we have a product of two functions. So let me show you what they're asking here. Or in fact, this one maybe is too similar to the other one. Let me do, because we have time, do you want to do a mechanics question? Yeah? Okay, let's do a mechanics question. Because the other one is similar. We can do it next week or the week after or something. So this one, these inclined plane things are again Jaffe-Ting questions. The key in these questions are to be able to find the components of the forces in the directions that you want. So when you have something on a slope, we are going to find the components of any force parallel to the slope and perpendicular to the slope. Yeah, parallel to the slope and perpendicular to the slope, because parallel is usually where the movement happens, and then you always have to work in perpendicular directions. Yeah, so parallel and perpendicular. So let's read the question. And it could be statics, so it could be that the particle is not moving, or it could be sliding down or going up. A box of mass 5 kilograms lies on a rough plane, so please highlight that. We are going to have friction. Inclined 30 degrees to the horizontal. The box is held in equilibrium by a horizontal force of magnitude 20 newtons, that you have it in the sketch. Is vertical, and the box is in equilibrium and on the point of moving down the plane. So it's not moving, but it's about to move down, and that information is important. The box is modeled as a particle. Yeah. First thing I would recommend you with these questions is to draw all the forces that you have. So before I do it, can you do the sketch and draw all the forces that you think they are acting? and in the directions that you think they are acting. So it's important that you draw vectors, so arrows, pointing in the direction that you think they are acting. So read it again if you need, but try to draw all the forces. Easy. What forces would you write?
I'm not actually sure. I'd probably say, well, there's friction.
A friction.
But
And if
also-
this thing is about to move down, in which direction will be the friction?
It would be pointing upwards. like-
Up the hill, and always parallel to the ground. Yeah. So this is the friction. What happens with this one?
That would be going down. I don't know if it'd be going down in the direction, but then would that be 5G?
5G in this direction. Exactly. And what happens every time we have things in contact? What other force are going to have?
I'm going up.
Which is what? How do we call that force?
The reaction force.
The reaction force, normal reaction. These are my forces. Yeah? These are my forces. Now I'm going to split them in wherever I need, but these are my forces. I have a weight always pointing down. I have a normal reaction always perpendicular to the surface. So it's not always pointing up, it's perpendicular to the surface. And because it's rough, I have a friction. And because this is about to move down, the friction is up. It's precisely the friction what this is stopping from moving down. Yeah. And then I have this force here. Now this is quite annoying when we have this force because the question becomes a bit messy. So now I'm going to write, or I'm going to find the components of the forces that are not in my two main directions, which are parallel and perpendicular to the slope. Yeah, I want all the forces in those directions. So these two are okay. These two are not. So this angle is 30 degrees as well. Yeah, so this angle is going to be 30. Simple trigonometry. I'm just using, so if you have a triangle, and this is the hypotenuse, and this is an angle, the opposite side is going to be A sine alpha, and adjacent is going to be A cos alpha. I'm just using that simple trigonometry. Don't think I'm using anything complicated. So if we look at this 5G force that is going down, this is a right angle triangle. This bit here is adjacent to the angle. So this component here, I'm going to draw a vector here. This is going to be 5G cos because it's adjacent. So probably you have done this. My students, we haven't covered this. Don't get scared because we haven't. But this is like in moments. In moments questions, remember, we are finding the component, the perpendicular distance and things like that. So this is very similar. And now the other component is going to be this one, that is going to be 5G sine 30. If one is cos, the other is going to be sine, yeah? Sine 30, this distance is the same. Now, I'm going to do the same with this one. So I'm going to find the component here, down, and the component here, down. So work with vectors, yeah? If this force is pointing this way, it's going to have a component pointing down and a component pointing up the hill, yeah? This angle is 30, the alternate angle. So this is 30. Which means this component, if you look at this right angle triangle, this component is 20 cos 30, yeah, because it's adjacent. So I have 20 cos 30. And this one here, if this is cos, this is going to be sine, is going to be 20 sine 30. The first time that you do a question like this one is super confusing. Then you do 3, and then you think they're all the same. Yeah? So don't worry too much if you haven't seen a question like this. Okay, so now this one and this one, they are vectors. So instead of working with the actual vector, I'm working with the components. So I'm substituting this one by this and this. And I'm substituting this one by this and this. Yeah? What are they asking me? find the magnitude of the normal reaction on the plane on the box. So we are going to resolve forces in the direction of the slope or in the perpendicular direction. They're asking me about this one now. So this is the one that I'm trying to find, R, the normal reaction. So I'm going to resolve forces in this direction. What does that mean? I'm going to write the equilibrium of my forces. So 20 sine instead of 20 electrica, thank you. So this is 20. I'm looking at this triangle electrica. So if this is 30, this is adjacent, so must be cos. And if this is cos, this must be sine, yeah, because it's the opposite. This and these are the same, opposite. Does it make sense? If not, you can stay a minute after. So I'm going to resolve perpendicular to the slope. Perpendicular to the slope, I have equilibrium. The thing is not moving, right? So the forces pointing in this direction, which is only the blue one, are going to be equal to all the forces pointing in the other direction, yeah, because they are in equilibrium. So R is going to be 20 sine 30 plus 5g cos 30. Yeah, does it make sense? So R pointing this way is going to be equal to the green and the pink. So let's going to do that. R is going to be equal to 20 sine 30 plus 5g cos 30. And we just find the value. It's one line and it's 4 marks. Come on, these questions, the minute you understand them, you're going to find them super easy. So this is 1/2 times 20 is 10 plus 5 times 9.8 and cos 30 is √3 divided by 2. √3 divided by 2. I get 52, if I've done correctly. I don't want to keep you much over the time. 5 newtons to 3 significant figures. Let me check the answer. Yeah. Yeah. 52.4 newtons to 3 significant figures. And the only thing I've done is find all the components of the forces that are not in the directions that I want, and then just find equilibrium. So in this direction, I have equilibrium. So forces pointing out of the surface equal to the forces pointing against the surface, just that. Now, find the coefficient of friction between the box and the plane. In which direction we are going to work now? In this one. And because I have equilibrium, just, that is not moving, I can apply equilibrium. So the forces pointing up the hill, that is the friction, and this green one here, both together are going to be equal to the force that is pointing down the hill, that I know you cannot see well, but is the pink going down, the component of the weight. Yeah. So I have friction up, the green up, and the pink down. So they are going to be equal to each other. That way, I will find the friction, and then I'm going to show you how to find the coefficient of friction in a second. So for B, now I'm resolving parallel to the slope, and I have that the friction pointing up plus the green one pointing up are going to be equal to 5g sine 30 pointing down. Yeah? Just equilibrium. Friction is going to be equal to, let's say what we get. I get 7.179 something. That's the friction. And now, again, this is year 13. Maybe you haven't seen this yet. When the friction is maximum, and that happens when things are moving or about to move, like is this case, we can say that that friction is equal to a coefficient of friction multiplied by the normal reaction. This coefficient of friction is just a number that depends on how rough the surfaces are. So the rougher, the higher the number is. It's just telling you how rough the surfaces are. And this normal reaction is the one that we found. They are asking us that coefficient of friction, and we have all the information to find it. So mu is going to be equal to our friction divided by R. Just that, yeah? So the coefficient of friction is this 7.179 divided by the 52.4. I should have kept more numbers in the calculator. And we get no, sorry, I'm doing the other way around. 7.1. I get 0.137, so I'm going to leave 0.14. Yeah. Let me check the answer. 0.137. So okay, or 0.14. Either. Does it make sense? I know these questions are really confusing at the beginning, but they are not that difficult. Look, the working out, and it's 9 marks, and it's 1, 2, 3, 4 lines. We could even squeeze it in 2 or 3. We draw all the forces. So it's important that you know in which direction forces are acting. The forces that are not parallel or perpendicular to the slope, we find components. This is vectors, simple vectors. We find the components of the vectors in the directions that we want. And then if the things are in equilibrium, we are just going to make forces in one direction equal to forces in the other direction. If this thing was moving, instead of equilibrium, we will be applying this. Yeah? So the resultant force will be the mass times the acceleration that this has. Imagine this is moving down with an acceleration. Yeah? And that's it. Any question? Aratrika, tell me.
I was just wondering, like, what would happen if you didn't have the horizontal force of 20 newtons? Then how would you find everything?
If you don't have, which is quite common, not having an extra force, and it's better because then you don't have this one, you don't have this one, and you don't have the components. In this direction, your normal reaction will be equal to this component of the weight.
Ah, okay.
And in the horizontal direction, the friction up will be equal to the weight down.
Ah, that makes
Yes.
a lot more sense.
Yeah, and in this case, if it could be that, so think that the component of the weight is what is going to make this slide down. If it's very rough, the friction is going to help things there. But if it's not rough enough, the weight will go down. So it depends. If there is very rough, this will hold the weight. If it's not very rough and the weight is large, it will go down. Yeah. So you won't have this one and you won't have this one. But equilibrium.
Okay, thank you so much.
No problem. Just the question would be easier. More questions? No? Okay, then I hope to see, well, I see some of you at 3:30, some of you next week, and some of you next time you join. Yeah. Happy New Year, everyone. Bye-bye.
Thank you.
Bye.
Thank
Bye-bye.
you. Thank you.
Bye-bye.
Thank you.
Miss, can I just ask you a really quick question?